Good day everyone. I hope everyone is safe despite of our current situation right now. So I'm Dr. Supache Basit, and once again I'm very much honored and privileged to deliver to you our first topic for the finals, which is about the hypersensitivity reaction. Now many immunologists would take note that there are actually several disadvantages of having a very efficient immune system. One of them is, of course, having the possibility of life-saving organ transplant rejection, and then having an efficient hypersensitivity immune system will result into hypersensitivity reactions. So, hypersensitivity reaction is a type of exaggerated response. So by the way, before I define hypersensitivity reaction, these are the outline of our topic for today. I will be introducing to you the hypersensitivity reaction, different categories, mechanisms, clinical examples, treatment, and lab testing. So, hypersensitivity reaction is an exaggerated immune response to a typically harmless antigen. In fact, you may not believe it, but a simple pollen or a simple chalk dust or the food that you are consuming could also be a possible trigger of hypersensitivity reaction. So, it would result into tissue injury and disease, and there are actually 4 categories of hypersensitivity reaction. So, these are classified as types 1, 2, and 3, and then we also have the type 4. So, among the 4 types, types 1, 2, and 3 are categorized as immediate reactions because the reaction occurs from minutes to hours after antigenic exposure. On the other hand, when you say delayed reaction, it will usually take between 24 to 48 hours before you can visualize any hypersensitivity reactions. So, it is also noteworthy to take note that types 1, 2, and 3 are antibody mediated, and type 4 is the only one that is cell mediated. So in fact, type 1 involves IgE, types 2 and 3 would involve IgG and IgM. And moving on, let us discuss first the type 1. Type 1 is also known as the immediate or the anaphylactic hypersensitivity reaction. So when you say type 1, the antigens that causes allergic reactions are also termed as allergens. So yes, if you're familiar with allergic reaction, that is considered as a type 1 hypersensitivity reaction. So they are common environmental substances that most people do not react to, but some people are quite sensitive when it comes to pollens, for example, when it comes to dust particles. So 10% of people who suffer from some form of allergy, and there is actually a very strong familial tendency. Okay? So type 1 hypersensitivity reaction, as what I told you, is also known as the anaphylactic hypersensitivity. So typically or commonly known as the allergies, and as what I told you, it is actually due to exposure to various allergens. Now, there are several key components of type 1 hypersensitivity reaction. So since it is antibody-mediated response, IgE is the main immunoglobulin that is involved. And aside from that, the participation of mast cells, basophils, and eosinophils would also play an important role in hypersensitivity reaction. So if you can recall what you have learned in Hematology 1, an increase in basophil and eosinophil may be reflective of allergic reaction. So there are several processes or mechanism involved in allergic reaction. So the first phase is known as the sensitization phase. In sensitization phase, there is no visual reaction yet. It is just the induction between the antigen and antibody. So if you can recall, APCs are the antigen presenting cells. Okay, so APCs would process allergens. Okay, so this would be the APCs, and they would process the allergen upon exposure. So this is like the first exposure with allergen. So the T helper cell that is involved here is known as the Th2. Okay, so the Th2 cells will induce the production of allergen-specific IgE. So with the use of interleukins 13 and 14, the B cell will eventually produce IgE. Okay, so IgE is now produced. So you have here the mast cells. Mast cells are tissue basophils. They are highly granulated cells, and during sensitization phase, the Fc receptor, okay, so this is the mast cells would have the so-called the Fc epsilon R1. Okay, the Fc epsilon R1 is the receptor site, okay, for the Fc part of the IgE. So if this would be the IgE, okay, let's recall. So this is one FAB, there's another FAB, and this is the Fc, or the fragment crystalline. The fragment crystalline is the one that would bind at the Fc epsilon receptor 1. And it is found at the surface of the mast cells. So during the activation phase is usually the second exposure with the same allergen. So if the first allergen was engulfed by the antigen-presenting cell, then the second allergen will actually bind with the FAB portion of the IgE. Since there are two adjacent IgE, so the allergen will cause cross-linking, okay, between the two adjacent IgE. So what will usually happen is that mast cells and basophils will degranulate, and then after the mast cells were degranulated, so you would see here in the illustration that it will release mediators of allergic reaction. So there are actually two types of mediators of allergic reaction. So the first one is known as the preformed mediators. So when you say preformed mediators, even before the sensitization has taken place, preformed mediators are already found as part, okay, of the mast cells, and they are waiting to be unleashed or waiting to be released. And the other type of mediator is known as the newly sensitized mediators, which means that they are just synthesized as a result of these particular processes. Okay, so the most common example of preformed mediator for allergic reaction, I'm sure you're very much familiar with it, and that is your histamine. So again, once the chemical mediators are released, it will now bind to the target organs. So what are the target organs? So this could actually be found at the target organs could be found, let's say for example, at the lining or in our lungs, or it can be found, it may also cause overproduction of mucus, or in some cases it may cause diarrhea, or in some cases the target organs are found in skin, and that is the reason why we have erythema as a result of allergic reaction. Okay, so again, as a review of the illustration, so this is an example of IgE found at the surface of the mast cells. So what are mast cells again? These are leukocytes with large granules, and it contains mediators of allergic reactions such as histamine. So when allergen is encountered again, so it's already the second exposure, it will cause cross-linking. Okay, and this now will cause the release of the content, which is the preformed mediator, and this is also the initial start so that newly synthesized chemical mediators will also be produced. Okay, so mast cell granules contains preformed mediators. So what are examples of preformed mediators? So this would include histamine, serotonin, eosinophil, neutrophil, and eosinophil chemotactic factors. Okay, so there you have it. Mast cells finally produce preformed mediators. So these are released immediately after IgE has been cross-linked. So as you can see here, IgEs here are cross-linked. Okay? So what will happen? Possible things that could happen are dilatation of the small vessels. So we call it the vasodilatation. And then there would be edema. Because of the vasodilation, there would be leakage of fluid, which means that interstitial fluid, for example, if we're talking about lungs, it will actually seep, okay, inside the blood, in the cavity, causing edema. So, usually people would complain, I have a feeling of parang nalulunod. Okay, if it's in the blood vessel, so there would also be edema. So in Tagalog, we call it namamanas. Okay, and smooth muscle contraction, and then influx of inflammatory cells. Okay, and histamine is the most important of these preformigators, and most of the over-the-counter drug would target on antihistamine, okay, as a treatment for many allergic reactions. So we also have aside from the preformed mediators, we also have the newly synthesized mediators. So when you say newly synthesized mediators, these are just triggered, okay? So whenever mast cell is triggered to release the contents of its granules, it will also produce newly synthesized mediators. These are in the form of leukotrienes, bradykinins, prostaglandins, and platelet activating factors. Okay, so these molecules will also result in vasodilatation, edema, smooth muscle contraction, and then there would be increased mucus secretion. So most of the time, patients will have difficulty in breathing. So that is the most common thing that would happen in cases of asthma attacks. And since prostaglandin is produced, it is the most common mediator for it is actually one of the most common mediator for inflammatory reaction. So there would also be pain, okay, as a result of the release of the newly synthesized mediators. So this is an example of an allergen. Okay, so the allergen will finally bind with the FAB portion. They're supposed to cross-link, and eventually the granules will be released. Okay, so what would trigger allergic reactions? So we call them allergens. So usually these would be triggered by pollens, molds, spores, animal danders, dust mites, insect venom, certain food. Although there is a familial tendency, which means that not all people would be allergic to peanuts, shellfish, or dairy products. So it depends from one person to another. So usually, if there's a history of allergens in the family, if it runs in the family, the offspring would also be allergic to certain allergens. Certain drugs, the most common drug that can cause allergic reaction is penicillin, and then of course latex. So that's why some people are having some sort of harmful reactions whenever they are wearing, for example, gloves that are made up of latex. So again, these are the common allergens, and possible clinical manifestations would include rhinitis. So rhinitis, this is the hay fever, yung mga tao na sneeze na para may mga sipon. So we call it allergic rhinitis. Asthma. And this could be fatal in some cases. Allergies to food, urticaria, or the hives characterized by the so-called wheal and flare, eczema. Okay? So if you have eczema, your skin, sometimes they call it skin asthma. So the skin there is like also wheal and flare that is also almost the same description, but in eczema it becomes very itchy, and the people with eczema would usually cannot stop but scratch their skin, and in some cases it will cause wound and secondary bacterial infection may come in. And of course, that the one that is also potentially fatal is systemic anaphylaxis. So the most common is, for example, when a person is exposed to jellyfish attack. So jellyfish attack may produce allergen. So usually the uh, the tentacles of, so whenever people would swim in, let's say, in the beach, they won't see jellyfish because they are transparent, especially in a very bright sunlight. And then the tentacles of the jellyfish is known as the cnidocytes, that is spelled as CNIDOCYTES. So in the cnidocytes, it has a transparent harpoon-like structure, so we call it as the nematocys. And whenever the nematocys is exposed to your skin, it will burst and it will now release the venom, which becomes the allergen. And in cases of massive jellyfish attack, it will cause anaphylaxis, systemic anaphylaxis, and it could be potentially fatal. Okay, so this is where you can find the different target organs. So if in the eyes, so it becomes teary eyes, the larynx, okay, in lungs, in skin, or even in nose. Okay, so treatment for hypersensitivity type 1 reaction, avoidance of allergen. If you know that you're allergic to seafood, then avoid consuming them. Drug therapy, such as antihistamines, bronchodilators, mast cell stabilizers, corticosteroids, epinephrine. Some of them are also anti-inflammatory. And then there is also an antibody against an antibody. So it may sound bizarre, but yes, it is in existence. So we call it the monoclonal anti-IgE antibody because it will eventually block the activity of IgE. And then allergen immunotherapy is also a possibility nowadays. It is by means of administering gradual increasing doses of allergen. So we call it the allergy shot or the hyposensitization therapy. So it is a process wherein the patient is injected with very small amount of allergens, and each week you increase the concentration. Okay, so eventually the patient will produce the so-called IgG blocking antibodies. So instead of producing IgE, okay, patients who undergoes this therapy will be producing IgG blocking antibodies. The blocking antibody is presumably will presumably mop up the allergen before it reaches the IgE on the mast cells. So what will happen? It has been suggested that hyposensitization therapy will act by inhibiting Th2, favoring IgG over IgE production. As we all know, we discussed a while ago that Th2, okay, will go to B cells, so that B cells will produce IgE. But because of the IgG blocking antibody, this particular technique or the hyposensitization therapy will prevent Th2 to produce IgE. It will favor IgG synthesis instead. If in case that IgE is produced, the blocking antibody will also target the allergen so that it will not reach mast cells that already contains IgE. Okay, so how do we know if you're allergic to certain things? So this is a time that we will be doing the so-called in vivo skin testing. So here it can be done either percutaneously or intradermal. So you have to apply a panel of allergens to different sites in your skin, and then since it is a type 1 hypersensitivity reaction, all we have to do is wait between 15 to 20 minutes, and a positive result is the wheal and flare at the site of allergic reaction. So let's say this person is allergic to spider, moth, caterpillar, and scorpion. I mean, who's not allergic to scorpion? And then honeybee, and then ticks. But interestingly, he's not allergic with house dust. Well, and with spider web. Anyway, there is also a specific IgE testing We call it the Allergen-Specific IgE Testing. This particular technique will determine or will detect IgE to a specific allergen in patient serum. So this one is actually more confirmatory as compared to allergen testing. Although allergen testing result will be available right away. So most of the allergologists would have panel available, okay, whenever you consult allergologists. By the way, allergologists, so we call them allergologists. These are physicians who specializes in the treatment of different kinds of allergy. Okay, we also have the total IgE. So it will detect the total concentration of IgE in patient serum. Okay. Moving on, let us now discuss the type 2 hypersensitivity reaction. So type 2 is known as the antibody-mediated cytotoxic hypersensitivity reaction. So it is also antibody-mediated because this would involve IgG and IgM. And in this particular case, the antigen is found on the cell surface. So since you have IgG and IgM directly attaching to the cell surface, okay, antigen found at the cell surface, okay, the possible effects of the antibodies would include cell destruction. So there would be cytolysis. So that's why it is also known as the cytotoxic hypersensitivity reaction, which will eventually inhibit the cell to do its function, or in some cases, increase in cell function. So, if you're familiar with the classical pathway of complement, which we have already discussed, okay? So, cell lysis is the end product of complement or the end result of complement activation, and there would be cell lysis, okay? And then opsonization and phagocytosis of the cell is the eventual cell damage, and this also may be manifested in cases of ADCC. ADCC is the antibody-dependent cell-mediated cyto-A. So clinical examples of type 2 hypersensitivity reactions will include transfusion reaction, hemolytic disease of newborn. Transfusion reaction is a type of cytotoxic reaction wherein a person is transfused with a wrong blood type. So let's say, for example, you're type A and you'll be transfused with type B. Okay, that's called blood banking. If you're type A, you're supposed to have antigen A at the surface of your RBC and if let's say you'll be transfused with type B, type B will have B antigen of the red cell and then anti-A in the serum. So the anti-A of your donor will eventually, okay, bind at the surface of the red cell of the patient. So what will happen? So there will be cell lysis. It is such a dangerous type of transfusion reaction, and in most cases, it could be potentially fatal. So we will be discussing later on HDN. We also have autoimmune hemolytic anemia. So if you can recall hemolytic anemia is a type of anemia wherein there is too much destruction of red cells, and this could be induced by warm reactive antibodies, which means that these antibodies react at 37 degrees, which is the exact opposite of cold agglutinins, because these antibodies would react at much lower temperature. And then we also have the paroxysmal cold, hemoglobinuria, good pasture syndrome, Hashimoto's disease. So these are all examples of type 2 hypersensitivity reaction. Okay, so let's discuss HDN, hemolytic disease of newborn. This is usually caused by development of antibodies by a pregnant woman to RBC antigen. Usually, it happens in RhHDN, or another type of HDN is the ABO incompatibilities or the ABO HDN. Okay, let's talk about the hemolytic disease of newborn. In this particular illustration, we will be focusing on RhHDN. Okay, So in RhHDN, let's set first some parameters, requirements. Okay, so the the first requirement is that the father should be Rh positive, then the mother, okay, should be Rh negative, and then the firstborn or the first child is Rh positive. So what will happen is that during the first pregnancy, because of the exchange of blood between the fetal and the maternal blood, okay, so mother's blood is Rh negative, right? So the RBC of the infant contains the antigen, and it will circulate in maternal circulation, which means that the first time that the mother's blood would encounter the D antigen coming from the fetus, that's what you call sensitization. Okay, sensitization. So in sensitization, the first child will be delivered safely because the mother hasn't produced antibodies yet. Okay, so no antibody production yet. Okay, so what will happen is that during the second pregnancy, because the first pregnancy is called sensitization, and then during the second pregnancy, so the mother has already produced anti-D. So in the exchange of between the fetal and maternal circulation, the maternal antibodies, IgG in particular, because IgG, as you can see here, this one is IgM, it cannot pass through the placenta, but only the IgG anti-D would be able to pass through the placenta. Okay? It will now destroy the RBC of the fetus. So what will happen? There would be a possibility of erythroblastosis fetalis, which means that it's gonna be a stillborn, which means that in most cases, the neonate or the neonate will not be able to survive. Okay, in order for us to prevent the RhHDN of the second child, we have to introduce RhoGAM treatment, okay, within 72 hours after the first pregnancy. Okay, so RhoGAM will prevent RhHDN from happening. So this is a classic example of cytotoxic reaction since the RBC, okay, contains the D antigen, and the D antigen is found at the surface of the RBC, and it is directly being attacked by the IgG anti-D, which is IgG in nature, okay, by the and that is considered as the maternal antibodies. It will directly attack the RBC of the fetus. So there you have it. That's an example of the RhHDN. Okay. There are several tests available in blood banking. So this particular topic will be expound further in blood bank. So we call it the direct antiglobulin test. So direct test. So if it's a direct test, it will detect RBCs coated with complement component or IgG antibody by incubation with a polyspecific anti-human IgG directed against IgG and complement. So here we're using cord blood as the specimen. Okay, so we're using cord blood. So if positive, the test is repeated with monospecific anti-IgG, anti-C3b, and anti-C3. So this will determine if indeed there has been RhHDN, or if there has been HDN for that matter. Okay. On the other hand, indirect antiglobulin test is also known as the Coombs test. Indirect, we call it the DAT. We're using cord blood. Here, we are using the patient serum because we are trying to detect antibodies to RBC antigen, which is the exact opposite of direct antiglobulin test, because here we're trying to detect RBC if there are any RBC that has been coated with complement component or IgG antibody. So here, we're trying to determine if the patient serum would have antibodies against RBC. So the usual process of indirect antiglobulin test is that we incubate the reagent's RBC with the patient serum at 37 degrees, then we wash it to remove unwanted antibodies or excess antibodies or unwanted proteins, and then we add anti-human globulin test and the same positive reaction, okay, which is RBC aggregation. Okay, having said that, it's now time to move on to type 3 hypersensitivity reaction. It is known as the complex-mediated hypersensitivity, or in some cases, we call it the immune complex. Again, this is an example of antibody-mediated hypersensitivity reaction. The key components are IgG and IgM, and this is directed against soluble antigen. So, what are immune complex? Or what is the composition of the immune complex? Immune complex is made up of the following. Okay, you have here the antigen, then you have here the antibodies, and then you have here the complement component attached at the Fc portion of the antibody. We call it immune complex. Okay, if I will be asking you, what is the most important characteristic of immune complex? Immune complex is soluble. Do not forget it. Okay? Immune complex is soluble, and since it is soluble, there is a possibility that the immune complex could be deposited, okay, at the basement membrane. Let's say, for example, in this illustration, this is an example of the basement membrane of the blood vessel, deposited at the wall or the basement membrane. So, again, this is the blood vessel. These are the endothelial cells, and then you have here an immune complex made up of, again, green is antigen. You have here antibodies. By the way, antibodies could either be IgG or IgM. And then at the Fc portion of the antibodies, the complement is attached. Okay? So immune complex is deposited now at the wall of the blood vessel. So what will happen? It will now attract macrophages and neutrophil. So as you can see in this particular example, neutrophil comes from different parts or at the adjacent tissue. And since these are endothelial cells, neutrophil would have the ability to undergo diapedesis. It will squeeze themselves out in between endothelial cells and will finally attack the immune complex. How? By releasing lysozymes, enzymes. So it will attack the immune complex. And they will try to phagocytize it, but it cannot be phagocytized because these are deposited in the wall. So imagine, you're trying to embrace someone, pero yung someone na yon ayaw magpayakap sa'yo, nakadikit siya sa wall, ang hirap i-embrace. So huwag nyo nang pilitin, guys. Mahirap talaga yumakap sa taong ayaw magpayakap sa'yo. Hugot. Okay. So it's like, di ba, kasi di ba, whenever neutrophil will try to phagocytize, it will extend its pseudopodia. Okay? Pseudopodia, and then will try to engulf it. So magkakaroon ng phagosome, phagolysosome. But it is impossible to phagocytize an immune complex that is deposited in the wall of the blood vessel. So, ang mangyayari na lang, neutrophil will release lysosomes, trying to target the immune complex, but in doing so, it damages the blood vessel. And it will result to vasculitis. Vasculitis is an inflammation of the blood vessel. And vasculitis is the manifestation of Arthus reaction, and Arthus reaction is the first experimental procedure done in animal to demonstrate type 3 hypersensitivity reaction. Okay? So, in type 3, or the immune complex, This is somehow similar to type 2. Why? Type 2 involves IgG and IgM. Okay. Same. Type 3 would also involve IgG and IgM. Okay? However, the IgG or IgM here will remain soluble in circulation, soluble immune complex. They will be carried out into the circulation and become lodged, deposited in the basement membrane. What basement membrane? Basement membrane of the skin, lungs, and joints. How different it is from type 2. In type 2, the antigen, as you can, in type 2, the antigen is part of the target cell. Okay, in type 3, antigen is not part of the target cell. Let me give you an example. Let's say in transfusion reaction, wrong blood type. A person is transfused with the wrong blood type. Let's say the recipient is type A. A type A individual will have antigen A at the surface of the RBC. So if you will be transfusing that person with type B, the type B person or the donor would have anti-A in his serum. So the anti-A will directly attack the RBC of the type A individual. So, question, where can we find the antigen? The antigen is found at the surface. And the antigen is the part of the cell. That is an example of type 2. Okay, do not forget, in type 2 cytotoxic reaction, the antigen itself is part of the cell. Or the cell itself contains antigen, which is different from type 3. Type 3 is that the antigen is not part of the target cell. In our illustration here, the target cell are endothelial cells. Okay, the target cells are endothelial cells. The antigen here are the green things here, the green illustration here. So when this neutrophil will try to attack the immune complex, instead of damaging the immune complex, what will be damaged instead are the adjacent cells, which in this case are the endothelial cells. So the endothelial cells are the target cells, which is not in any way part of the antigen. Okay, I hope you understand it. Okay, so to give you hopefully a much thorough understanding, again, these are the epithelial cells. Okay, and then you have here the immune complex. Okay, deposited here at the surface of the epithelial cells. Neutrophil will try to attack the immune complex, but instead of attacking or damaging the immune complex, it will damage the adjacent epithelial cells. So in this case, the target cells are the epithelial cells, but not the antigen. In type 2, when you attack the antigen, the target cell is also the cell that contains the antigen. For example, RBC. That's type 2. So at what particular part of our organs or of our body can this immune complex be deposited? So remember, immune complex is soluble and they can be deposited in the blood vessel, in kidneys. For example, good pasture syndrome will damage heart and kidneys. Okay, joints, skin. Okay, so you will do not be confused that in some cases you will find literature that good pasture is type 2. In some cases, good pasture is type 3. Do not get confused, okay? If the cell itself contains antigen and it becomes the target cell, and if that one is damaged as well, so that's type 2. But if the antigen is not part of the target cell, then that's type 3. Ganun lang simple to differentiate type 2 and type 3 hypersensitivity reaction. So again, Type 3 hypersensitivity reaction occurs whenever there is an immune complex that is deposited. Composition of immune complex, antibody, antigen, and complement. So, it will be deposited, okay, at the wall of the blood vessel, okay, and many cells will try to target the immune complex, but instead of damaging the immune complex, it will damage the adjacent cell, which in this case, the walls of the blood vessel. Okay, sorry for that. And the complex deposited on the vessel wall, okay, the neutrophil will try to destroy them, and eventually, okay, it will damage the wall. So and then later on, there will be platelet aggregation causing microthrombi, small clots. This will interfere with the local blood supply, and eventually it will result into a chronic. So, type 3 hypersensitivity reaction could be manifested in the form of autoimmune disease. So, a good example of that is rheumatoid arthritis. In rheumatoid arthritis, the immune complex is deposited at the synovial joints, tulad for example sa knees. So there will be inflammation in the joints. Okay, so the joints will be damaged. Okay, the synovial membrane will be damaged. Hypersensitivity pneumonia, infection. It could also be drug-induced. Okay, so drug could serve as an allergen in which antibody will stick into it and complement will bind with it, causing us to have immune complex which eventually could also be deposited. So, Arthus reaction, I think I've told you already that this is the first experimental demonstration in animal to manifest hypersensitivity reaction. So here, the allergen is inoculated or injected into the experimental animal from the epidermis, and then antibodies will bind with the antigen and then complement. Eventually, this will be damaged within 3 to 8 hours upon the attack of the neutrophils. Serum sickness is also an example of hypersensitivity reaction. So here, it is caused by passive immunization of humans with animal serum. Alala niyo sinabi ni Duterte na yung gamot sa COVID-19 galing sa kabayo. Actually, it's true. Because most of the antibodies, kasi whenever we want to produce antibodies, we want to produce antibodies from large animals so that when we harvest antibodies, it's more efficient because you can have more antibodies. Unlike, for example, if you will be choosing mice, which is also possible, but for mass production, blood coming from mice is very minimal as compared to horse. So, horse serum is one of the most common sources of antibodies, especially anti-rabies. Okay? So, hopefully, they would also be able to mass produce antibodies against COVID-19 from horse serum. So, here, can you just imagine, we will be receiving antibodies coming from horse serum. Horse, humans, not same species. So, produce antibodies against the foreign animal proteins in patients, which means that since you are not a horse, you're human. So whenever you'll be injected with horse antibodies will have proteins, animal proteins, and animal proteins are considered as antigen. We do not consider that animal proteins as ourself. Non-self yun. So, what will happen? Magkakaroon ng immune complex. Okay? So, what is immune complex? Made of, in this case, immune complex, our own antibodies, plus the horse protein. Let's say if you're getting horse serum, so there's a horse protein plus complement. It will be deposited in our tissues. So, what are the signs of having serum sickness? Headache, fever, nausea, joint pain, rashes, and lymphadenopathy. Okay? So, after injection of drug molecule, it may combine with self-proteins to form antigen. The host react and produce antibodies. First, there is little antibody, so there's an antigen excess. After 7 to 10 days, ito na nga yung signs, eel rash, fever, vasculitis, and joint pain. Good thing about it is that as more antibodies are produced, the conditions will eventually be cured. Okay, so these are the things that we need to undergo to, okay, in cases of receiving passive immunization from animal antibodies. So this is another common manifestation of serum sickness. So other conditions associated with type 3 hypersensitivity reactions, autoimmune disease, SLE, which we will have a separate discussion of autoimmune disease later on, reaction to bee stings, okay, drug reactions, okay, and sequelae to infection. Let's say, for example, post-streptococcal glomerulonephritis. So after you have been infected with streptococcus, glomerulonephritis is a possibility because immune complex is deposited at the basement membrane of the kidneys. Laboratory testing. Actually, we will be discussing more of the ANA, anti-nuclear antibodies in autoimmune disease. So we will have a thorough discussion of that. Fluorescent staining, testing for rheumatoid factor, again, it will be discussed in autoimmune disease, and testing for complement levels, which have already been discussed in, I discussed that to you, that topic to you during the prelims. Okay, so the last type of hypersensitivity reaction is called the type 4 hypersensitivity reaction. It is the cell-mediated hypersensitivity, which is, of course, the delayed type hypersensitivity reaction. So here, it is not the Th2 that is involved. Okay, do not forget, Th2 is involved in allergic reaction. Here in type 4, we have Th1. So Th1 cells and macrophages are involved. So APCs will present antigen to naive T helper cells. So when you say naive T helper cells, this particular type of T helper cells have not yet been exposed to any type of antigen. Okay? And it will differentiate into Th1 cells. Okay? Eventually, the Th1 will produce cytokines that will also activate macrophages. Okay? And macrophage is the one that will induce the inflammation. Okay? So, as inflammation is induced, cytotoxic T lymphocytes are recruited and eventually will destroy target cells. However, since it will take between 24 to 72 hours before there is a physical manifestation of hypersensitivity, so this particular type of hypersensitivity reaction is called the delayed type. So usually, the delayed type hypersensitivity reaction is the result of infection with intracellular pathogens. This include Mycobacterium tuberculosis, Mycobacterium leprae, Pneumocystis carinii, Leishmania species, and herpes simplex virus. Contact dermatitis, which we will be discussing later on, is also an example of type 4 hypersensitivity reaction. Contact dermatitis usually happens. Have you ever noticed if you've been wearing eyeglasses? So personally, I stopped wearing eyeglasses that is made up of nickel because usually I'm having contact dermatitis here. Makaka-relate talaga yung mga salamin. Or if you've been wearing nickel watches, or in some cases, if you've been wearing fake jewelries, so there's a possibility of having contact dermatitis. Diba? Some people would say, ayoko magsuot ng peke, nakakati ako. That's somehow true because if it's made of gold, usually it will not cause contact dermatitis of a real gold or pure gold. Okay? And then hypersensitivity pneumonitis. This may be due to allergic diseases of the lungs caused by inhalation of bacterial and fungal spore. So, example, farmer lung disease, bird breeder's lung disease, humidifier lung disease. Okay. So, I will be discussing here contact dermatitis. Okay. So small molecules react with proteins in the skin to form antigens, which provokes cell-mediated immune response. In this case, our example would be poison ivy. Okay. Poison ivy has, whenever you touch poison ivy has the so-called urosols. Okay, so that's the active substance found in poison ivy. Type 4 hypersensitivity or contact dermatitis is not only manifested upon exposure to poison ivy. So like what I've told you, nickels, cosmetic, hairspray, dyes, and even formaldehyde may be the possible sources of contact dermatitis. Nickels, most common yung sa eyeglasses and in watches or bracelet, okay, or a necklace. So in contact dermatitis, there is a low molecular weight compound, okay, that will come into exposure to your skin. So since it is low molecular weight, it is not really an antigen. We call it hapten. But hapten, even if it's low molecular weight, hapten is enough to synthesize Th1 cells. So katulad nga ng poison ivy, poison oak, nickel, salts, materials in cosmetics, hair dyes, and even the latex. Okay? So there would be skin eruptions, as you can see here, erythema, swelling, and papules. Papules here are produced. So what happens? Okay, during first exposure, poison ivy, upon contact with poison ivy, urosol, this is an active substance in the poison ivy, will bind to protein in epithelial cells. So that becomes the hapten and becomes sensitizing antigen. So it is actually enough to synthesize the Th1 or the TDH, that the delayed hypersensitivity cells, that their matching antigen receptors will come into contact with antigen, and then they will proliferate clones which synthesize the individuals. So you now have clones of Th1 or the TDH, the delayed hypersensitivity cells. During second exposure, so makulit ka, you touch the same poison ivy. Okay, it will now activate the TD cells, and since it has already been activated, it will eventually proliferate and produce lymphokines or cytokines, which will stimulate macrophage to attack the target cells. In this case, the target cells are the epithelial cells. So there would be itchy, painful dermatitis of poison ivy after 48 hours. Kasi nga, macrophages will now attack the epithelial cells of your skin, and that is considered as the target cells. Okay, so applications of delayed hypersensitivity, in skin testing for in leprosy, we call that the lepromine test, tuberculin test. Okay, so that's an example of hypersensitivity reaction. Chronic inflammation with Mycobacterium leprae and Mycobacterium tuberculosis will cause skin and lung granulomas respectively. That is also an example of delayed hypersensitivity reaction. So let's go to skin testing. In skin testing, so for example, you will be injected with tuberculin. In tuberculin testing, you will be injected with PPD, purified protein derivative. Okay, and then after 3 days, you will go back to the site wherein you injected the PPD, and then you will measure the diameter. If the red exceeds 10, if the red erythema or indurated or thickened due to lymphocytes and macrophages exceeds 10 millimeter, that is considered as a positive tuberculin test. So here, using tuberculin syringe, you inject the purified protein derivative. So what does it mean? It means that you are already exposed with Mycobacterium tuberculosis. Okay? So it can be done, this method is the MAN2 method. In MAN2 kasi, you are injecting it intradermally. You are injecting the PPD, purified protein derivative. Okay, so this one, a positive test is induration. Erythema of more than 10 millimeter. And then, Patch test is also a possibility. You just apply patch in the skin. Okay? So, test for contact dermatitis, redness with papules or tiny blister is considered as a positive reaction. Okay? So, let's go here to the table. So, here we have the three common types of type 4 hypersensitivity reaction. So, the first one is called delayed type. And the most common example of proteins here or antigens here are proteins such as insect venom, such as the bee stings, mycobacterial proteins such as tuberculin and leptin. Contact hypersensitivity, the consequence of this one is local skin swelling, erythema, induration, cellular infiltrate, and dermatitis. Contact hypersensitivity, the most common type of antigen here are the one that is found in poison ivy. So we call them the haptens because they are low molecular weight, small metal ions such as nickel and chromium. Consequence would be local epidermal reactions such as erythema, cellular infiltrate, vesicles, intraepidermal abscess. And then we also have the gluten sensitivity enteropathy, also known as the celiac disease, because of the antigen known as gliadin. So there would be atrophy of the small bowel, of the small intestine, and if there's a venous atrophy, you cannot absorb nutrients, so there would be malabsorption. So yun. That's an example of gluten sensitivity enteropathy because it affects the small intestine. So there you have it, the 4 types of hypersensitivity reaction. I hope that you learned something in this particular screencast. So please do not forget to study and stay safe, and please comment down below. Okay, so your comment your insights, and that this will serve us. Okay, so stay safe and God bless everyone.